What's up, guys? So today I was going to make a new video about shift registers and how they work and the two main types of shift registers, and I'll show you guys a couple of things you can do with shift registers. Get that out of the way. So there's two types. There are parallel in, serial out, and there are serial in, parallel out. And two examples are these are the 74165 respectively and the 74595. So I'll go over the serial in, parallel out first. So over here is a schematic of the 74595, and I'll make a simpler drawing of it. So let's just say that this times 8 is all of your outputs, Q0 through 7, okay? And that should cover, this whole thing and this. And then, you got your VCC and your ground. So yeah, we just eliminated like 10 pins. So output enable. So if you want your output to be enabled on this chip, it's a active low, sorry. So you're gonna want to bring output enable to ground. And then master reset, you might want to put it to a push button or something, such as like this. It's the worst button. So this would be your master reset, which is also active low. So you're gonna want to have it pulled up high with a, let's say, a 1K resistor to positive, and over here on this side you could put ground. So whenever you press it, it will reset your shift register and clear it out. And you'll see how that will work in a minute. So ignore pin 9 for now. Pin 9 is just for attaching multiple shift registers, and I'll teach you guys about that in a second. But for purposes of this basic introduction to how it works, we don't really need that pin. What we need to focus on is DS, STCP, and SHCP. And I will put these pins on this side. So DS is your data. Okay? Now, STCP is actually your, it's your latch. So STCP, which is your latch. And all these words will make sense in a minute. And your SHCP is the clock pin. CP is the clock pin. Now, all of this might sound like Chinese, so let me show you guys a little bit simpler. So you'll put a push button over here, and this is for the most basic demonstration of how you would use this. You'd put a push button over here, and these are going to be, this side will go to high of the push button, and then you'll pull it down to ground with some resistors on the input, pull down resistors. This one goes high. Same thing with data. You're going to want to put a pull down resistor to ground, and this side goes to high. Alright, so let's say you had a pattern. Let's say you had a pattern like you wanted to shift out, I don't know, 1 0 1 0 1 0 1 0. So the way that you would do this first is you would leave all of these alone for now, and then you would press your DS data button, making it high, and then you would press the clock button, okay? And then you would press the clock button again to shift in a 0, and then you do the first thing that you did and press the DS and the clock until you have pressed each of these 8 times. You have to do this, and then you will press the latch, and you will have that pattern outputted. So a simple way I can put it is that this clock will shift in whatever is on the data pin. So if the data pin is not being pressed, it will shift a 0 to the right, and whatever was there will go to the right. So let's say you had a 1, and then you had 0 0 0, the first thing that you put for this pattern. So you'll have 3 4 2 3 4. Now if you press it again without pressing the data pin, you'll have 0 1 0 0 0 0 0 0. So now you'll press it with the data press the data pin first and then the clock pin, and then you'll have 1 0 1 0 0 0 0, and you just keep on doing that, and then press your latch, and that would finally output whatever you were doing, which will be that pattern. Now I'll go over the 165 very briefly. So this was 74595, which is this one is serial in, parallel out. So now we'll go over parallel in, serial out. So with the 74165, you're gonna have, 4 5 6 7 8. Pardon my garbage handwriting. These are your 8 inputs parallel. Okay. Then you have a shift / load, and load is active low, and then you will have a push button for that as well. And then you have a clock pin, push button for that as well. You see how these things kind of correlate, but how they're kind of opposites? You'll see in a second. Then you have your serial out. Now, every time that you hold shift to load and press your clock button, you will get each of these, whatever this is. Let's say it's the same pattern. Let's say it's 1 0 1 0 1 0 1 0. Every time that you do that, you will get, you'll get it the other way around. So you'll get, 0 1 0. Because it needs to. I'm not sure. Right now, when I think about it, I'm not sure if you would. Actually, yeah, you would get the same thing, because I think it starts from here. I was kind of forgetting if it starts from here or here, but it starts from there. So if you connect these two together, so if you put this serial output, get rid of this push button on 74595, and you connect this serial out, and then you hook up the clocks to each other. This is the clock, and you hold this button, and then you clock it in, and then you press the latch button on the 74595. You would have successfully shifted this data out from this register into this register. And that's awesome, because I was using only 3 pins, and that's really useful when you're using something like an Arduino and you want to control a lot of data, a lot of inputs and a lot of outputs with only a few pins. And you could achieve that whether you want to control a lot of inputs or a lot of outputs using these 2 different types of shift registers. Now let me show you built up on a circuit. So this is that exact circuit that I just showed you, with a 74165 over here, and the clocks of them are hooked up to each other. This is the clock pin of the 595 and the 165, and this is the shift / load, and this is the master reset button, and I'm going to press that right now and reset it. This is the latch, and this is the pattern that I want to write out. So the pattern is, these dip switches are kind of hard to see, but there's a 1 0 0 1 0 0 0 1, and I want to shift that data out. So what I got to do is hold the shift / load. So right now it's in load because it's active low, and I have it pulled down. Now I want to go into shift. So I'm going to hold this button and clock each piece of data in to the 595. And these buttons are not debounced, so it might not be right the first time. Yeah, I had a feeling that would happen. Let's do it again. This is just the most annoying circuit. I don't think that's going to be right either. You need to use a microcontroller if you really want to do this correctly. Great, there's a horn. This isn't going to be right either. This breadboard is garbage too. Let me try again. This is really frustrating. Let me clear the shift register again. This time I feel like it'll work. Come on. Nope, that's not the correct pattern. Yeah, it's really hard doing this with push buttons because these breadboards have a lot of parasitic capacitance, but I just want to demonstrate that this does work. There we go, that's the correct pattern. And it actually does do it backwards when you do shift out, I believe. Yeah, so it's 1, if you 1 0 0 1 0 0 0 1, it's 1 0 0 1 0001. So that depends on, it's because of this chip is shifting it out from left to right, I believe. So that's that built on the breadboard, and you could hopefully maybe understand a little bit better what's going on. But if you don't, I'll just put it in like the simplest way possible. This chip takes, the 165 takes 8 inputs, and it has one serial output. Serial meaning 1 bit, and it goes to the 595's DS pin, which is data. And every time that I press, if I hold this button and then I press this clock pin, it will shift that data in. Okay, and then I press the latch and it latches the data in. And the master reset, I'll just reset it, and let's try it again and see if it works. It probably won't the first time. I haven't been very lucky with that. Yeah. When you do this with the microcontroller, it works perfectly though. Not correct. Yeah, what the hell? There, yeah, there's your correct pattern. Now, you guys might be thinking that there's something wrong with my circuit or that I built it wrong. Well, you're wrong, because I did build it correctly. Just the problem is literally the breadboard, and the buttons aren't debounced, and I'm not really going to go too much into how you would fix that, because I don't really care, because this is not how anyone uses a shift register. Now, away from this irritating circuit, let's go over to something cooler. So, this is a Knight Rider, 16-bit Knight Rider, and it was made using a ATtiny and two 74595s. The ATtiny is just a little EEPROM that you program with an Arduino, and this is the pinout. As you can see, I'm only using 3 pins from the Arduino or the ATtiny, whatever, and they're going to the shift registers. And now you can see that one pin, that Q7S, that pin basically goes into the next shift register, and that makes sense because it's your last output. Q7 gives Q0 through Q7, so that goes into the next shift register. Okay, and then you start shifting with that one. Now, the way that you would write that in code is something like this. So over here I have the code. This is where I define my pins. This is the pattern. That's the Knight Rider pattern. And then I have this index. I start at 0. That's going to be the index of the Knight Rider array. And then this is where you determine the size of the array. So to determine the size of an array, and this is true for C++ as well, so basically what you do is you take the size of the array, like the actual amount of memory that it takes, and divide it by the size of the 0th element, or any element really, element x, or whatever element it is. So basically you'll get how long it is, because let's say I have an array of 20 ints. An int is 4 bytes. Okay, 1 int is 4 bytes. And let's just call this index, I don't know, 1. And then I have 20 ints, so there's 80 bytes total. So if I take 80 bytes and divide it by 4 bytes, you get 20 ints. So that's how you determine the size of an array, and that's pretty simple. And then over here in void setup, I just set up these 3 pins as outputs, the SHCP, STCP, DS. Again, that's what they are: the latch, data, clock. And then down here is where it's pretty much gets simple from here. So I made a method called EasyShift. It takes in an integer array and size of the integer array. So digital write STCP low, so I'm putting the latch low, then I'm shifting out this data, most significant bit first. Doesn't really matter if you do LSB or MSB for this project. The type is this array and of that index, so I'm starting at index 0, shift out the first 8. That's what this is. So I'm shifting out the first 8, letting that first shift register chill out while I shift it through the next shift register. And then digital write the latch high, so you get your data in, and this is just for just one, I guess, iteration through this array. And then you delay for 50 milliseconds, increment your index to go to the next one, and then once you hit the last index, start over again. and then I just put that into my void loop. Now I'll include this code and this schematic in my description, and that's just the last view of what this Knight Rider looks like. And yeah, so I hope you guys learned a lot about shift registers. Thanks for watching.